breaking a CAPTCHA. This one is going to use CAPTCHA images, so you just download them. I made a limited set of them and put them on my website. You can use a bang inside Python to execute shell commands outside Python, at least in Google Colab. I don't know if that works in other Python environments. That's pretty cool. So you can download and unzip things. So you get the content2, which is a list I made that includes a subset of the original images, and then there's a Python script helper that's used that you download. And then you run this, and now you can print some of the images. And this is just a bunch of images that are sort of tilted. It's from a WordPress plugin to make a simple CAPTCHA that just takes like 4 different fonts and tilts the letters over randomly to make the letters, it moves them a little randomly to make the letters a little scrambled. So here's one kind of R and there's another kind of R. So it's a pretty weak CAPTCHA. And so you have to do some code to reduce all the images to 20 by 20 grayscale and save the labels to mark the correct letter for each one. So here's the extracted letter images, and here's the labels, and this processing just does that. And then you create a model and train. And so we're going to have the first layer here with 20 by 20, which is the input pixels. Then we have a layer here, which does a convolutional layer, which I think is just some kind of image transformation. And here's the one that does the work I understand, hidden layers with 500 nodes. That's 500 intermediate nodes to do the, okay, and good, somebody says the bang is specific to Jupyter notebooks. I'm glad to know that. All right, and then the output layer with 32 nodes, because there are 32 possible letters. The input data here had all 26, it started with 26 letters and 10 digits, and then it excluded a few that were really too close, like 0 and O. So there are really 32 possible inputs. And so you define the layers, then you compile the model, and then you have a summary of the model, and then you fit the model, do it for 10 epochs. And so you'll see after train it, you get up to 93% accuracy on the data. And the model summary will show you the layers. So you have the input data is 20 by 20 by 20, I think. And I thought it was just 20 by 20, so I'm not quite sure what's going on here. First number seems to repeat for something. Here's 20 by 20 images. And then you have this pooling layer and this convolution layer, which I don't really understand entirely. There's a link at the bottom of the original blog that might explain it a little better. But then we get to the intermediate level. I guess this 10 by 50, this is the 500 in the middle. So I'm not too clear about this one. It'll be more clear in the future. Anyway, we end up with 32. You see how well it works. So that one I ran. I wasn't that good at understanding all the details at this time, but then I found the second textbook, and I'm getting to understand it better. So